right? If you need to produce a YAML, your but this is different because you need to produce the single whole and then Okay, let's move the discussion for later. I guess there's a lot going on here. But at this time, let's welcome Alex. He's going to talk about LSP in configuration languages and how we can support developers in using configurations. Take it away.
Yeah, awesome. Yeah, so this is a talk on utilizing the language server protocol to inform and teach users about configuration languages. And I'm Alex, and I work at Google, and I work at Google on the GCL team, the language that everyone has been talking down, which I will talk down also, so don't worry.
I knew you would.
Yeah. Yeah, so let's just start off by going over what the LSP is. The LSP is Microsoft's language server protocol. It defines the protocol that's used between a text editor or an IDE and a language server. And a language server defines the semantic features of a language, such as go-to definition, what is available for autocomplete, and find all references, and some others that we will cover later. There's at least 20 or more LSP methods that you can implement to do a lot of different things. And the reason to use an LSP is because almost all modern IDEs and text editors support it, and that's where most of your users or all users in general are editing files nowadays. And it's not just Visual Studio or VS Code or IntelliJ. It's also Emacs and Vim have extensions and plugins to support them. And another reason that you should do is you don't have to write front-end code for extensions on or plugins and stuff for IDEs, as us language developers don't like to do that kind of stuff. Yeah, so I will go over the GCL language a little bit. We've heard the horror stories, but now we will see some of the actual code. So the GCL language is a Google internal language, and that will be important for later. But it is declarative and dynamic, and what that means is what you see usually is what you get at the end. It's not like you're calling a main function and that's going piece by piece. There's a lot, GCL is one of the most used languages at Google. I'm not sure if I'm allowed to say that, but it is, and the reason is that it does a lot of different things. And the way that it can do a lot of different things is that there are a lot of different versions of the language. So you might be writing in 5 different versions of the language in your day-to-day job, and you might not necessarily even know that you're writing all of them are at the base of it GCL. And importantly, it's almost no one's main language. No one is sitting there every day writing GCL. They write GCL when they have to write GCL, and when they're told to write GCL, or when something breaks and they have to change a GCL file. And so, similar to most configuration languages, developers occasionally use the language. It has drastically different paradigms from their normal, everyday languages. And how the GCL file is evaluated or used is almost exclusively defined outside of the file. Nothing here is saying how these values are used in an actual program that's using the configuration. Oh, I forgot one of the last bullet, but I talked about it, so that's what is important. Okay, so how are we using the LSP for GCL users, to help GCL users better use and understand the language? So one of the big issues with GCL, of many, is that GCL doesn't really have a type system. I mean, it has a lot of different type systems, but it doesn't have one real type system. GCL has 3 really popular type systems, and then for the hundreds or multiple hundreds of dialects, a lot of them have their own little type systems as well. And so as a user editing a GCL file, if you're writing in one dialect, that's why you might not know that that two different dialects are both GCL is that like they're evaluated differently a lot of the times because the type systems for those dialects are very different. The type system is not visible to the user. Like the user will not see types. It's usually defined in the interpreter where like the two different parts of the interpreter that are supposed to do the same thing will do different things. So like if you use the code in one way, in a different way, the type system is different. And then a lot of the type system is done on output post-processing, like when you get the output of the configuration. And generally, users rely on tutorials or documentation to write their file or to edit their GCL file because none of the type information is in the file itself. And what this really means is that users copy and paste all their code because they have no clue what it does. And they have no clue how to write a file. Yeah, so that's a lot to try to fix. So the real way to fix it is to add a real type system to GCL. And that is a goal we have, but that's probably going to take 10 years or more. And obviously we want to integrate that into the IDE. But in the meantime, as was mentioned earlier, we want to shift left. We want to move the hidden semantics of the language and the multitude of dialects into the IDE so that the user understands what's happening as they're editing, like in the way that they actually use the code or interact with the code. And the way that we want to do that to start is by providing the shape of the configuration that they're expected to output where they're actually writing it, and provide the documentation for the things that they're trying to write. Let's see this. Oh, okay, actually, this is a good thing. So this is not a real GCL dialect. I had to write a fake one, so if it looks really like not good, it doesn't make any sense, that's why. But yeah, so we are opening a GCL file. We are told to edit a front-end service, but when we just open it, like we don't necessarily know what any of this does. Like it's long, like this is a small GCL file comparatively to most, and it doesn't expand to the right like most do. So we're editing the GPU of this front-end service, and we're told to increase the memory of the GPU. And we get there and we're like, 2. What does 2 mean? 2 doesn't mean anything. And so we're like, I guess we want to increase it, so let's go to 5. Like, is this a percent? Is this like a multiplier? Like, sure, let's just try that and see what happens, right? And see what happens is not a good thing for configuration. And so what that really means is people are going to have to like look up documentation. If it exists, it usually does not. They're going to have to ask around because that's how things generally are defined as word of mouth. Or they just don't look it up and they just fill something in. And so if we look at the same file with some like semantic features embedded into the LSP methods, it's a little improved. So as we open this file now, we can see these things that are underlined. The underlined words are document links for the LSP. And what that means is that if you control-click on the underlined part, it will either take you to a portion of code or it will take you to an external link. And so the reason we are using this method is that it brings users to the attention that there exists documentation for these fields that they can read about and like to help them understand the things that they're doing. So if we're going to do the same thing that we did in the last thing, change the GPU requirement of the front-end service, we go down to the front-end service. I don't know if it shows it there, but we're in the front-end service. We go down to GPU, and if we want to read about what the GPU values are doing, we now have a link we can go to. I wasn't going to create a fake website, so it doesn't go anywhere. But also, if we hover over the field itself, now we're provided the field information of that. And so we now know that the 2 means 2 gigabytes. And we're like, okay, I know what 2 gigabytes is. And like 3 gigabytes sounds reasonable. So we're going to increase it to 3. And this is a pretty simple example. But let's say we are also told to add CPU requirements. Under GPU, one might expect CPU to exist. So we press enter, and now we're provided the expected fields that we're expected to output for the configuration in this file. And so we know that CPU is a thing. So we can enter on CPU on the suggested field, and we're suggested now the subfields of that shape that we're expected to fill in. And as you can see, it also now provides the information about the field on the right-hand side. So the whatever that field is, I can't read it. It's an integer, but it told us that it only takes 1, 2, 3, or 4. Now that could be embedded in other parts of the language, but it's important to have it in the documentation as well. And we go to the same thing that we had for GPU, right? Minimum memory or something memory. But this time it said it was in kilobytes. So we're going to do 128,000, I think, kilobytes, which is 128 megabytes. And to us now, we understand the difference between those two numbers, the 2 or the 3 and the, oh, that disappeared really quickly. Oh God, this is going to work. Go. We understand the difference between these two numbers, and when another user comes into this file later to edit it, they'll be able to understand the contextual difference between those two numbers also, because they can hover over and see, oh, this one's kilobytes and the other one's gigabytes. It makes sense why one's much different than the other. Yeah, so what we're trying to do with this is reduce the ambiguity in how users fill in their configuration. We want to remove the ability for them to do things that they shouldn't do by only suggesting things that we know that they should do. And from this, we hope to reduce outages from misunderstandings, like that gigabytes versus kilobytes, and stuff like that. That's where a lot of configuration issues come about from. And we want to also reduce the time spent learning how to read and write the languages or the different dialects, because that's like we want to improve. We want to reduce the time that people spend in these languages because it's not their main job. And so we don't want them to have to spend a whole day reading the documentation for this, the new dialect that they're trying to use. And this also provides the dialect owners the ability to have more control over how users use their dialect in the editor by providing these this automated way of showing them the type system information in the file. Because we generate it from the actual dialect implementations themselves. Like we don't want to have, like as someone mentioned earlier, you don't want to have the two sources of truth because they could go out of sync. So we generate all this information from the source of truth itself, and then it's reflected to them in the IDE. And for how it has improved users' experience, we have noticed since implementing and pushing this to our users, we can see how all of our users interact with this because all of the users of this language are in Google. So this is one of the nice things about it. We can see that hovers went up 50% when we implemented the semantic assistance, which is like the doc links and stuff like that. And autocomplete acceptances went up by 30%, which leads one to believe that these are helpful suggestions to the users and helpful information that we're providing. And after using them for certain dialects, users started pouring in requests for additional dialects that they use to have support in this system. Another issue that GCL has that I mentioned earlier is that it is a dynamically scoped language, which is bad. If you don't know, lexically scoped is the way to go. Here's an example of the dynamic scoping. In the return field, the helper, when it tries to output return.info and it calls helper, you can see above that helper calls something called base website, a reference base website. Base website is not lexically available to helper, but when it's called from the return object, a base website does exist there, so it knows like dynamically it is available. This is bad. We don't want users to use this. We want to disable all dynamic scoping it for GCL, which is not possible currently. But we want all future code to not have dynamic scoping. And so by just implementing the LSP methods for lexically scoped values, we push users to actually like write lexically scoped code. Like if we're trying to write the same function that we saw before, we go here, base website is not available to us in the lexical scoping. And so we're like, oh, maybe we shouldn't use base website. So now we know we need to have some base URL that exists in the lexical scope that we can then append to. And now this, the autocomplete shows us the lexically scoped value, and we're like, okay, that works. But base URL is empty, and we want to put something into the base URL, and we know we need to do that when we call helper, and so this is going really quickly. And so when we fill in base URL, we now are suggested the lexically scoped base website from that tuple. And so now, after using the LSP features, we push the user to write better lexically scoped code and go away from the bad things. Yeah. And so the results, it's hard to get user sentiment on this because we don't know if they would have written bad code previously before they submit good code. But we do know that like go-to definition use skyrocketed after we enabled it. And we only provide lexically scoped go-to definitions. And we also had autocomplete of references be used much more higher than we expected, which also implies that people are using lexical scoping more often, hopefully. And in conclusion, the LSP can be useful for many things, especially for configuration, because a lot of things exist outside of the file itself for configuration languages. And so moving that information into the editing experience, we have seen to be a positive experience, a positive improvement for users, and a way to test new versions of language features that we want to add, like the type system stuff. Yeah, and of course restrict the bad parts of the language that we hope to eventually remove and cut away. Yeah, and that is it. Thank you so much.
Thank you, Alex. Okay, we have the first question already. There we go. Marcus, you want to set up?
Do you do anything for telling users about provenance of values, like where they come from, if default values have been overridden, all these kind of things?
Yes, we can give them the provenance if it is not a default value, if it's been set somewhere else. We can take them to the original field that it was set from. We haven't, like, default values are a thing that we want to do in the future. Oh, sorry. But we haven't gotten to that part yet. No.
First Daniel.
Hi. Yeah, that's very cool features. The examples that you showed, they showed like LSP features that most of us, I guess, saw in other languages already, like the IntelliSense stuff, for example. But recently, especially, there has been like tons of ideas and extension requests for LSP for fancy visualizations like trees, graphs, whatnot. Are you also thinking into some of the new stuff, some of these complex visualizations to leverage these for GCL?
Yeah, we have been trying to, like debugging of a configuration language can be really difficult, right? And so we've been trying to use to move a version of our debugger into the IDE experience via some of these new things, because we don't really work, the GCL language wouldn't work with like a stop debugger or a breakpoint debugger. And so we're trying to use the new methods for that.
Nice talk. I guess if you were to consider refactors based off of, so if you take your dynamic scoping example and you have the information that says this variable is not in scope, kind of suggesting a refactor to code written like that, would that be something that is still within the LSP, and is that something you've considered, or would that require like an extension?
Yeah, so there's another issue there, that this is a basic example of dynamic scoping. The bigger issue is if there was a variable that was lexically scoped, but there's a closer definition that's dynamically scoped. At runtime, it will use the dynamically scoped value and not the lexically scoped value. And so that's where it really becomes an issue. But yeah, like that's the thing that stops us from being able to use the refactoring tools and stuff like that, is because of the dynamic scoping.
Yes, thanks for. I think that's a very valuable addition, because you can add all kind of fancy type system or have something like Haskell, but if the only error you get is something is wrong, you cannot. So I think this is much more valuable than some other more fancy stuff. I wonder, one interesting thing I think with a language like Q or Nickel or DAL that tries to be the lingua franca of configuration is that what it brings is you have only one LSP, and somehow it is configurable or extendable thanks to types and contracts and whatnot. So you said that you extracted the thing from dialect definitions. Is a dialect specific to one application, or is there a lot of, if I want to write my new service and it has like custom configuration fields, how hard it is to write some kind of specification for the LSP to action?
So we, like, to allow for the different ways that dialects are implemented, like I created like a API where they just have to define like a basic schema of how types are evaluated in the dialect, and then automatically fills in all the LSP methods for them after they implement like the 2 or 3 methods of the API. Yeah, and then, but no one does that, so I actually write all the definitions for each of the dialects, but
Hi, thank Alex again.